Alright guys, we're on page 91 of your student journal. I wanted to break this section up into two parts because it's kind of a lot to digest. So we're on page 91, even and odd functions. So even function, odd function, let's get some definitions going. So even functions, you can go ahead and copy these in your definitions, all of this text right here. F of negative x equals f of x. The y-axis acts as a mirror. So what does that mean? If I plug in a negative x, the y will remain the same. So if we look at this, if I fold it in half along this line, the graph will be exactly the same as it is on the left. Same here, and so on and so forth. And so then, that's it. If you plug in a negative x, you get the same exact y as if you plug in a positive x. And the y-axis acts as a mirror. Okay, moving on. Odd functions. So, actually, if we go back, and the y-axis acts as a mirror for even functions, what do you think would act as a mirror for odd functions? And so some of you might think, oh, if you flip the x-axis acts as a mirror. So if you use this, then as a mirror, then you're pretend it's actually on the x-axis. Then it would look like this and this. But then that would not be a function. It does not pass the vertical line test. So, yep, doesn't work. So an odd function is when it's reflected on both axes. So what does that mean? So first I will take this, let's just focus on the right side of the graph. And I will take this and I will reflect it across this line. Then it will look like this. Somewhat, maybe not so low. And then if I reflect it now across this line or axis, then this will go from being down here to up here and downwards. And thus, we have it. We've reflected it twice and it worked. So that would make an odd. So it requires two reflections, one across the y and one across the x-axis. Evens are just straight down the middle, mirrored there. Lastly, we have neither, functions that are neither. So if I take this and I split it down the middle, well, it would be over here, but it's not. If I mirrored it again to see if it's odd, I would have to mirror it all the way over here. So this would go down here and be reflected like that, which it is not. Here cannot be split, mirrored here. And if I mirror it again, it still doesn't make sense. Here, if I mirror it, then it's not a perfect mirror. This is not the same on the right as it is on the left. And lastly, if I mirror this one's kind of close. If I mirror this, it will start here. Sorry, pretend it's nice. And then if I mirror it again down here, then it would go like that. But it does not go like that. It starts up here. So it's not a perfect, mirror two times. So that's the graphic, the picture version of it, of even and odd functions. You should copy those definitions on page 91. Odd functions, f of negative x equals negative f of x. So when you plug in a negative x, the y becomes negative. The function is reflected on both axes. Here for even functions. Now I'll show you some algebra. So we have these functions where you substitute, or you already have a positive x, and we will need to substitute a negative x. And if it's even, and I'll just type it, I'd rather type it. If it's even, it will be the same result. If it's odd, it will be the opposite result. And what do I mean by that? So if it's even, the same thing would be 2x. But if it's odd, the opposite would be negative 2x. So I'm going to go ahead and plug in a negative x. So f of negative x equals 2 times, but instead of x, we're replacing it with negative x. What's 2 times negative x? And the answer is negative 2x. So is this odd or even? The answer is odd. Okay, so that's that part. Now let's erase that. And let's talk about the next one. If it's exactly the same, it will be x squared. If it is opposite or odd, it will be negative x squared. So let's plug it in. What is negative x times negative x? What is negative x squared? And the answer is positive x squared. So what is this? It is even. Right? And lastly, for this to be the same, it would have to be x plus 2. But for it to be opposite, it would be negative x minus 2. So let's plug in a negative x. We get negative x plus 2. Is it the same? No. Is it completely opposite? No. So this is neither. That's neither. Okay, and that applies to 1, 2, 3, and 4. So again, you would just, for all of these, you would substitute a negative x for all of these. And you would check. If it's the same, it's even. If it's opposite, it's odd. And then if it's neither, then it's neither. So here, what would be the same? The same would be negative 4x squared. And the opposite would be positive 4x squared. This one, the same would be half x squared, but the opposite would be negative 1/2 x squared. So I'm not writing answers. I'm just writing things that you would compare it to. So you would compare it to 1/2 x squared and negative 1/2 x squared after you replace this with a negative x. So for instance, 5 times negative x is negative 5x. Well, it's certainly not the same, so it can't be even. But is it the opposite? Yes, it went from positive to negative. Then it is odd. Okay, and then for this last one, you would see if plugging in a negative x squared makes it the same, or if it makes it the opposite. And when I say opposite, that means I just change all the signs. Okay, so that's it. Hopefully you understand. If not, Google is your best friend. How to find odd and even functions, or you can ask me as usual.